Okay, brilliant. I'm going to share a few resources today. I think the demos that I'm going to go through are going to take about maybe half an hour to 40 minutes. We've got more time than that scheduled in this slot. The demos that I'm going to show are quite generic, and I'm sure that the teams are going to come up with a range of different technology ideas and solutions. So what I thought we'd do is I'll go through 3 demonstrations of different technologies that you could utilize. And then the rest of the time is an open session for you to come and ask any questions. My expertise is in Python. I'm a fellow of the Python Software Foundation. I've written books on Python and authored lots of tutorials and stuff and videos online. When I've been working as a researcher specialized on Python over the last, while. I can't teach you Python in 2 hours. If you had the expectation, I hate to disappoint you. But I can share a couple of things which are specific to AI and ML. So hopefully we can go through those. It actually struck me when I was studying at university cybernetics, which we did quite a lot of AI at the time. We didn't have any of these libraries, and it just blows my mind now how many resources there are available to people. Like when we do a neural network, when I was at university, you used to have to sit and write the whole thing from scratch in C++ and look at the textbook and see how the person in the textbook did it. There was no package to go and download and run it all for you. So yeah, I'm very jealous. It just means I think the problems that you're working on now are more complicated because all the basics have already been solved. Okay, so I've got a little scratch pad that I'm going to paste in the chat window now, with some links to resources that I thought would be useful. So I'll just quickly talk through those. There's a link at the top to register for free Azure resources. And I'm going to show a few of the technologies that were just covered by Thasmika in the last session. And I'm going to show how you can get up and running with some basic data analysis. I'm going to share my screen. Okay. Hopefully everybody can see this. Okay, cool. So I'm hoping everyone's familiar with this site. If you're not, then I really recommend you check it out. This is data.gov.au. I was looking for a data set that was interesting this morning that I could use as a demo. I've also been awake since 4 a.m. watching the soccer, so had plenty of time after that finished. So data.gov.au is a Australian government site with loads of data sets across different areas. All the individual states submit data up to this, and I'm aware that there are data sets for this hackathon as well. I just picked one of these because I don't want to show something that's actually related to your topic because that might be cheating. So this has got absolutely nothing to do with assessments. It's a data set of the water quality in specific areas since the bushfires. So the particular metrics were the pH levels and the dissolved oxygen. Basically anything with a low dissolved oxygen means that fish can't survive. So anything below 4.0 means everything in that lake would die. And when there are a lot of fires, the dissolved oxygen levels would drop. Which means that our marine life can suffer. So first things first, if you go and use this link at the top to register for free Azure resources, that'll give you access to the free tiers in Azure. And from there, you'll get access to the Azure portal, which is where I am now. So the first thing I'm going to do is I'm going to create a machine learning workspace. So at the top, in the search box, if you search for machine learning, and then up here, you can click on create. It's just going to ask you some basic questions. Resource group, if you don't have one, just click on create new and give that a name. I've got one already. called Hackathon. Give it a useful name so that you remember what it is. And under region, your best bet is to select Australia East, which is in Sydney. So that's going to be nice and close. Pretty sure it's near Macquarie University, actually. So that's probably in North Ryde, actually, that data center. So yeah, that will be nice and fast, and it's going to create a few additional things for you. You can leave all these settings as they are, as default, and then go ahead and click Review and Create. I've done one earlier, so I'm going to skip that step and jump into my own workspace. So once the workspace has been provisioned, on the overview page, you'll see this button here, which says Launch Studio. So we're going to go straight into here and open up the Azure Machine Learning Studio. So in my workspace, I've been working on a couple of experiments to look at this bushfire impact water quality survey to understand what happened to the dissolved oxygen levels since the fires in 2020. And the first thing you do to set that up is you go to the Datasets tab, and you go to Create Dataset, and then from Local Files, give it a name. This is a file, and then you go to Next. That's right. You go to Next, and then upload your file, and it will be given a name. In my case, this is a CSV file that I've downloaded. And click Upload, and it will upload that into your workspace for you. So I've done that already. This is the water quality CSV file that I uploaded here. It was specific to Lake Conjola, I think that's how you pronounce that. I don't know where that is, but that's the one that I picked. It was the top of the list. And inside that data set, you can click on that and it would pop out to let you see that data set. So now that we've got the data set in our workspace, there's a couple of things. There's two approaches we can go with here. One is you can go to the Notebooks tab, and you can click Create New File, and then create a new Jupyter Notebook. If you're familiar with Jupyter Notebooks, which I hope you are, they're a combination of Python programming as well as the ability to annotate things and describe. And it integrates graphing capabilities into the environment. So I created one earlier on called Water, where I was just having a play around with the data to see what I could find and what was interesting. Now, there's a new button up here that I want to highlight to you that says Edit in VS Code. VS Code is a free code editor that Microsoft makes, and it supports Jupyter Notebooks and Python. Strongly recommend you download VS Code, and when you have done, you'll be able to click on that button. Before doing that, you need to provision a compute environment because this code needs to run somewhere. So we do that by going to the Compute tab, clicking New, and then giving it some information about what compute cluster we need. In the free tier that I linked to you at the beginning, you get a certain number of hours for free. So the compute cluster you used won't be charged. Just make sure you shut it down when you're finished, which you can do by stopping the cluster. So I've built one already. Actually, I've built two, but the second one is the one I was playing with this morning. And for that compute environment, I can click on VS Code, and it's going to pop up in this one. It's going to pop up in VS Code and show me all the files that I have in here. So in that environment, you can create a new IPYNB file for your Jupyter Notebook. And then for the dataset, if you click on the one that you uploaded and go to the Consume tab, it will give you this little code snippet, which helps saves you having to type all this out by hand. But you can copy that and paste it into your Jupyter Notebook. What that's going to do is basically connect to your workspace, download the dataset, and then make it accessible to you in a variable called files. So all I did next is import pandas, which is a common data processing library used in Python. Hopefully you're familiar with this already. If you're not, the basic API for pandas would be to read the data from a source, whether that is an Excel spreadsheet or a CSV file, or maybe even a binary format. So in this case, this is a CSV file. If I look at that in VS Code, I can see it's basically a list of the estuaries, the logger, the water logger, the sample depth, conductivity, temperature, water temperature, and then that was the dissolved oxygen level, the DO level. So I want to bring in this data and do some simple work on it. So from pandas, you just read that file, and in the Jupyter Notebook, you can press play here to execute that cell. Visual Studio has got a built-in data visualizer, so this works with pandas data frames natively. So if the last variable on the line is just the name of the data frame, then it will visualize that for you. So here you can see the output. So in this table in particular, I was interested in the dissolved oxygen level and comparing that possibly against the temperature. I wanted to see whether in the warmer months, the temperature had actually improved the dissolved oxygen level. So I wanted to see if there was a correlation between those two values. So everything you now do is within the Jupyter Notebook, and this is essentially running the notebook on your machine, but it's connecting to Azure's ML compute cluster. So I've opened this notebook locally, but I haven't had to worry about configuring Anaconda and all the dependencies and everything. Notice how Pandas is already installed and configured, as is tools like scikit-learn, matplotlib, and all the other Python data science tools you'd expect to be available. So if you just plot that data frame, typically you don't plot the entire thing. You'd pick some of the columns first, but the graphing is then rendered and built in to Visual Studio. So this is you would do in Jupyter. If you're using an online notebook, you can do all this within VS Code. So as a demo, I wanted to see, okay, if we plot the date against the oxygen levels, what can we see from that graph? And we can see this drop off here around February 2020, as you'd expect, where the oxygen levels in the estuary drop significantly, and the magic number is 4, and at times actually drop within the 4.0 number, which is really bad. So yeah, we can see that there is a correlation here between the event on in February 2020, which is, I guess, towards the end of the bushfires, and then this significant drop off beyond that point. So like I mentioned before, your data science libraries are already pre-installed within this notebook environment. So in this sample, this is just a basic linear regression, which you can import from the scikit-learn modules. So what I wanted to do was just demonstrate how you can apply a linear regression algorithm to X and Y, which I did as temperature and oxygen levels, and then just show that graph. Now, the output of that was quite considerably useless, actually. There's clearly no regression here at all. And actually, this seemed like more of a clustering question than it was a regression question. So I think in the output, I looked at this and went, okay, that tells me nothing particularly useful. But is there anything in the grouping between these values? So at the bottom, we've got temperature, and on the side, we've got the oxygen levels. And I'll share the code for this if you want to copy anything that's in here as a sample. This is just standard scikit-learn code, along with matplotlib for plotting the regression line. And then scikit-learn also has a series of clustering algorithms you can use if you wanted to apply a simple k-means algorithm to that group and ask for 3 clusters and then fit those groups. So looking at temperature and oxygen levels. And then you can also ask for the centers of the clusters, which typically called centroids. And then on the scatter chart, add those as red dots. So we can apply that simple ML algorithm to group the data together and see, okay, we've got this warmer temperatures up here above 27 degrees where the oxygen levels are still considerably high. We've also got between 24 and 27. Here we've got the yellow values where the oxygen levels are acceptable. And then there is obviously this cluster here, which is the lower temperatures where there is a normal oxygen level. And then this massive group here, which is showing us the issue, which is below 6, between 2 and 6. So the oxygen levels here are dangerous to marine life. So this is just a demo Jupyter notebook that I put together to show how you can connect the Azure compute environment into a basic Jupyter notebook. You can edit that live in the browser here. So I'm looking at the same notebook that I had in VS Code running in the browser. And there's really not much difference other than you're just running this in the web browser, and you can edit the code in the browser as well, and you'd get the all the plotting and stuff like that that you would expect in the same functionality. So the second thing I wanted to share was, I guess, that's the Python side of things. So if you're familiar with the Python tooling and Jupyter notebooks, this is a great way to get up and running, to work with big data sets in particular, because the compute environments you can provision can scale up to terabytes of memory. So hopefully the data set's not that huge. Otherwise, we might be here for a while, but you can configure the compute environments up to larger scales. Something else that was shown in the last session was the kind of the drag and drop designer. So if you go on the left inside the Azure ML site to the designer tab, then you'll get the ability to design pipelines. So typically you'd combine a pipeline with some data processing work that you've done, whether that is in pandas or an experiment maybe you've done in Jupyter notebooks, and you've created a process data set. You can also do data processing in the workflow. If the data set that you're working with doesn't need a whole lot of data processing before it goes into the models, you can just create a pipeline straight away. So let me show you one example that I was working on this morning. So when you create a new pipeline, you get this library on the left-hand side, and there are all these different, basically these steps that you can drop into your workflow. So the steps typically follow the sequence of importing the data. So you would go and grab the inside the data input, you grab the import data step, and then you'd give it the data store, click on browse, and then find the data set that you uploaded earlier. Convert that to a data set. So basically it processes that CSV file into a format that any of the data models can understand. Narrow it down. So I'm only looking at temperature and the oxygen levels in this particular problem. So you just select the columns. You can do additional steps here in data transformation, such as you can merge multiple data sets together using some sort of join operation. You could remove or replace missing data values. You can do normalized data, which is another useful step. Any of these things, remove duplicate rows, actually, that's a very useful one. So if you just drop that in, and it's just going to ask you for what is required. So date time was let's say we had 2 captures on the same day. We could add that step in there. And then I can just put this in our workflow like this. So it's going to say, okay, if there are two recordings on the same day, then only keep the first one and delete the second. So you can just basically drag and drop any data processing steps you want into the workflow. Narrow down that data set into something specific to the algorithms that you want to do. And then typically, if you want to use this pipeline to compare models, so the first time you design the pipeline, typically what you would do is you'd pick some algorithms that you want to try and some parameters that you want to experiment with. And then you split the data between a training set and then a modeling set. So you can do that using the split data step. This one you can split by rows, or you could split it by an expression instead. What percentage do you want to go out into the first data set and what percentage in the second? So 0.5 basically says 50-50 between the training set, which is the left-hand side. So it goes to there, and then that will be the model set. So that's on the other side. So if we change that to 0.2, so 20% of the rows would go into the training, and then the others would go into the scoring algorithm. You can swap that around. You experiment to see how the data set applies in your cases. Then in terms of the actual algorithms, you can then go into the machine learning algorithms group. And then there are regression, clustering, and classification algorithms, which you can drag and drop, which still blows my mind, but you can just drag and drop them in here. It does definitely simplify things. It really helps if you understand the theory behind the algorithms, if you want to optimize these. So, for example, if I wanted to, in this case, basically what I was trying to do was compare linear regression and a neural net regression algorithm to the same data model and see which one was more effective at spotting a data trend. So that's why I've basically created 2 branches in the pipeline here. So the input to this branch is the neural net regression model algorithm, and then the input to this branch is the linear regression. So I go through the same steps, which is to train the model based on the training data set. And then the next step is to score the model, which you compare the training output data versus the split data that we had earlier. And the scoring step, will basically take this data feed and apply the parameters of this algorithm to that input feed, and then compare that with the actual data and see how effective that was to come up with your RMS error values. So creating those things together, you can merge the two and run an evaluate model step. And then lastly, drop summarized data in there, which will help you compare the outputs of the 2 algorithms. So if I jump back, because I did actually run this earlier. So once you've run your pipeline, then you would have the outputs viewable in the browser. So you can look at the outputs of any of the steps, any of the stages. you can look at the summarized data, which basically will excuse me, allow you to graph and download that information. So if we click on preview here, it's going to tell us mean absolutes and RMS error values for the two different algorithms. Well, actually, it's summarized the two, but you can download that data to look at and compare the effectiveness of those two different algorithms to that particular training model. So that's the second demo. I think if you know and understand these algorithms, then this will make sense, and it's a good way to experiment with different parameters. And I think to train a model against a data set to something which is optimal. However, you need to have an understanding of whether this is a regression issue, a clustering issue, or a classification issue. You need to understand that first before you come into this pipeline. And then the last thing I wanted to share was something else which was mentioned, which is the text analytics services in Azure. And these are part of their cognitive services APIs. So I've, again, put some links to training videos and links to the SDK and everything you need to get started with that. If you go into the Azure portal and you search for text analytics, and then go to create, and then you can create if you just do skip on that first page, and then again, pick a resource group, a region, and a pricing tier. The one you want is their free tier, which gives you 5,000 transactions per month. Configure all of that, and then accept the responsible AI terms at the bottom. Put that in Australia East, so it's nice and close, and then put it in the same resource group as the one you had before, and then go ahead and click create. I've already made one, so I'm not going to make a second. I just wanted to show you where that goes. And then once that's done, there's not a whole lot you can do in the browser because this is an API that you've provisioned. But the tab that you need to go to once that has been set up is this one here, which says keys and endpoint. That's going to give you the API endpoint that you connect to using the Python SDK, the text analytics SDK, and it's also going to give you two API keys. So in this link, the bottom link, which is called Text Analytics Demos, if you go and open that up, it's a GitHub repository that I put online with some Python demos and everything you need to just clone this repository and experiment with some simple demonstrations of what the API can do. So I'm going to go ahead and open that locally on my machine. The thing you need to create is a .env file locally, and inside that env file, you would paste in this code, which says the analytics endpoint and then the API key, which I'm going to reset after this demonstration's finished, but just to show you where it goes, you'd paste in those two values. You got those from this portal here. So that key is this one, and you copy that and then paste it into your environment file, copy the endpoint and paste it into here as well. In terms of the demonstrations, they're demonstrating different features of the SDK. Maybe some ones that you might be interested in would be key phrase extraction. So this demonstration will look at 3 sequences of text. So that's this one, and this one. And it's going to look at key phrases in that text and extract those and summarize them for you. So to run those in VS Code, you'd go to the Run and Debug tab, go on this drop down here and find the extract key phrases sample and click play, and it will run that code in your integrated terminal. So it said Key phrases in Article 1 were beautiful season, clear of view, blue sky, yellow leaves, Washington, etc. And then in Article 2 and Article 3. So what's happening in this SDK example is we're giving it some text. We're using the text analytics client to connect to the API. And then we're actually getting the API to do the heavy lifting of analyzing that text for us. You definitely need to understand the question that you're asking before you talk to the API. So in this case, we're looking for key phrases in this text and whether or not they exist. So we're looking to see any mentions of Microsoft in each of these documents. And you can then print a result to say, here are the articles that are mentioning Microsoft. So, we could use this for looking at news headlines or social media or stuff like that. Some other samples in this repository are sentiment analysis, which probably doesn't play that much into marking, whether or not people are happy in their submissions. I'm not sure how helpful that is, but there's definitely analyzing actions is a particularly good example, and recognizing entities and linked entities. So if you actually want to do sort of rich text analysis, then there are some deeper examples in here that would show you how things relate to each other. If you've used a library called NLTK before, the Natural Learning Toolkit, which is a Python library, this is similar to NLTK, I guess, but the API is much richer, and the lexicon and stuff that it uses is a lot more developed. And the other one, I guess, that might be useful is the language detection. So if you're working with multilingual inputs, it can process those for you and work out which language code they're assigned against. So those are my 3 basic demos. And again, the links for everything that I shared is in the chat window. Everything here is free and online and available, including all the learning modules, the technology samples, and VS Code and all the extensions. If you do have any questions, technical questions, or anything else comes up, I'm going to be available all afternoon, and I will be online as well tomorrow. So I'm available if anybody needs for assistance.